Well, then I want to give you a quick introduction to the exercise tools, and then we will just straight jump into kind of the hello world of Dusk, some very simple initial exercises. They're kind of focused more on pointwise stencils, but tomorrow when we learn all the other language elements, we will do much more interesting stencils. So first, I would like to introduce you to Binder, or specifically mybinder.org. This is an online service for building and sharing reproducible interactive computational environments from online repositories. That's what we will use for the exercises. It allows us to give you a free public access to Jupyter Lab notebooks, and it supports running Docker images, which gives us full control over the environment, such as dependencies. And all you have to do is open the link in the browser, and hopefully we will not have technical issues. So also at this point, we really want to acknowledge the great work of Binderhub and its kind of 4 main partners. They've been very supportive. We're very thankful for their very great servers. And so maybe also a quick anecdote here. So for workshops, workshops are allowed to use this service for their notebooks. And if you expect a high number of attendees, you can request bigger slots, a higher amount of resources, and that's what we did. And they granted that to us, and then they've been very, very good to work with. They've, I think, really nice documentation, and they allow us to give you a really nice solution. Also a bit on this Binder thing. So every instance has a minimum of 1 GB, and you can get up to 2 GB of RAM. It is only CPUs, so there's no GPUs. Getting free public GPUs is very difficult, but CPUs will be enough for our exercises. Also, please be a bit patient with the startup times. They can be between 5 to 10 minutes, but if it takes longer than that, then it probably makes sense to start a new instance. And hopefully, on average, this will be between 1 and 2 minutes. Also, please only open 1 single instance in your browser. Like I said, there's a limit on the available concurrent sessions. I don't think we will hit this limit, but if people open this in many tabs, then we might kind of get to hit this limit accidentally. So please make sure you only have 1 instance. The sessions the documentation says the session times out after 10 minutes. In practice, I found that it takes a bit longer than that. But so just so you know this, after 10 minutes of the activity, you can expect a timeout, and you might have to restart it. But I think that should be no problem. You can also shut it down manually, and I will show you this very soon. And then alternatively, you can use a Docker container locally. And so here is basically the link, and then I will show you this in a second. And alternatively, you can use this Docker command to run the whole thing locally. And it kind of gives you, you're then free of those limits, and then basically the exercise will run on your CPU. So if you have a beefy machine and Docker setup already, this might be an attractive way to use it. So there's no time limit here and no limitation on resources. And you basically just copy the whole multi-line command. Actually, I'll do this in a second, and then I will show you what this looks like. And I will give you the introduction now, and here's also a link to the documentation. Maybe also work on video codecs. So for some exercises, we display some videos, and you need to have support for this H.264 codec. This is a very, very popular codec, and hopefully this your machine will be fine. Otherwise, we found that Google Chrome bottles them automatically, so you could try one of those. The other browser. And there's a test here where you can check this. And now I want to kind of show you this whole thing. So I will copy this comment okay, hang on. Actually, let's open the link first. So I can copy this link, and we can open this in here in Firefox, and I'll show you what this looks like. So here it's starting. And here you will see what it kind of does, gives you a sense of progress. And if it takes a long time, you can also have a look at the content down here already. So in the content folder are exercises. And I will actually start off with this introduction, and I will show you this notebook here. But actually, we're lucky. This time it started really, really quickly. That's really nice. So I couldn't show you this. That's, I guess, the demo effect in a positive way. But if it takes a long time, you can at the below the log file, you can see already look at the content in a non-interactive way. So you can already read the exercises. Now I want to show you real quick this Docker comment. So I'll copy this real quick. Just the comment here. And basically, I need to execute this with administration rights. And if I copy this, then I have to type in my sudo password. Oh, I got it wrong. Yeah, okay. So this time I got it right. And then you will see kind of it will start this Jupyter software, and you'll see a login here. And at the end, it'll print these links here. And basically the link with 127.0.01, that's the one that you can use. So I will open a browser here, and if I open this link in the browser, I will be connected to my local session here. And basically this session here, which is running locally, it's exactly the same as this thing running online, but again, you don't have the time limitations, and if you have a beefy computer, this might be faster for you. So in this kind of folder here, we have all we have a folder for all the sessions, and there's an intro folder with a notebook that I want to show you, and we will kind of just go through this thing, and actually, yeah. So quickly, an introduction to Jupyter Lab. So this notebook that I will present here, that's already in the file. So if you missed something, you're welcome to kind of read this up again. It's all written in here, and I will kind of go through it very briefly because I think most of the interface is very intuitive. So on the left-hand side, we have a file explorer. So for example, I can go here in this home folder. I can look at these folders, and then I can navigate. And for example, I can look at this first exercise. That's what we're going to solve today. I can open it, and then, for example, I can open this exercise notebook, which opens then here. I can also, for example, look at files. So there's a driver file that I can open, or a make file. Now, most of these files are not really interesting because that they're not. We don't really present them as part of the exercises. And then two cool things are that you can upload your own files. So for example, you can upload some other stuff in here if you want to. And you can also, for example, you can download these files. So if you do right click on a file, you have this download option here, and you can download them. Then there's the launcher feature. So in the top, if you press this plus, you can open new notebooks. So you can open a Python notebook, and then you have a new one. They can also open a terminal, but the terminal support is not that good. And you can get the same functionality in a notebook. You can additionally open a console, and then you kind of have an interactive console where you can execute commands. So we can do a hello world here, and if you press Shift Enter, this will print here. Maybe also a hint. So Shift Enter usually just runs your code, and if you press Enter, you will just get new lines, and if you press Shift Enter, you will actually run it. And then in this case, this is not valid Python code. So much for the launcher. I think the notebook launcher is kind of the most interesting. So if you use these Python notebooks, I think that gives you the best functionality. Then there's a bit of the windowing system support. So for example, I can take these tabs, and for example, I can have a side-by-side view. This might be interesting. For example, I can have my first exercises, let's say here on the left, and I put this console here at the bottom like this, and then I can arrange them however I want. So if you have a bigger screen, then you can do this. I mean, my screen is fairly big too, but I changed the resolution so that it's visible on smaller screens too, and you can arrange these windows however you want. I think that's a fairly nice feature as well. But let's close these for now. And we continue with the introduction. Then kind of this area here, that's the actual notebook, and all around here, these things are like the lab interface basically. So the notebooks is kind of where the exercises happen, but there's quite some nice support around that. So then we have some code here. This is this notebook consists of cells, right? There's like here a cell, here a cell. Oh, something happened here. And here a cell, and so on, and consists of cell. And you can have code cells. So this is a Python code cell where you can write code. And then we can, so here's another code cell, and we can execute this. And we execute this here with this play button at the top. And basically it will execute the code and it will print it worked here at the bottom. And then also sometimes a cell can take longer to execute. So this cell kind of has an artificial sleep comment in here. And if I execute it, I can see that it takes a while to execute this thing. And while it executes, you will see here this star. And the star means that it's running basically. It's either running or it's waiting for a top cell to start before it can run. And yeah, basically this is all kind of controlled like with this top bar here. So you can play these cells, and then you can restart the kernel, and this can be good because all these cells, they execute kind of in the same Python environment. And after a while, it can happen that you kind of, there's some state that in this Python environment where things kind of break apart, and you might feel like, hey, something weird is going on. And then you can just restart your Python environment here. And then what's also useful is you can restart it and you can run just everything in here. And that's also really good to do because basically most of these cells, they only run if the cells above ran as well. So it makes sense to kind of restart and then run everything. And then, after everything has been run, all the variables have been set, all the ports have been executed, and basically then you can kind of re-execute cells again. And then next, and these Python cells, you can also execute shell commands. So I think that's a better way to execute shell commands, and all you have to do is kind of prepend this with this exclamation mark. And then also, there's more documentation if you want to find out more in general about that. I think generally it's fairly intuitive, and then I think you'll get the hang of it fairly quickly. So then I want to say a few words on the usage of the notebooks. So here we have a Dusk stencil, and then we can, as we've seen in slides, and we can translate it with this Dusk API. So this is here it's used, and then we can convert this callable object from Python. So this is the name of the stencil here. We can convert this to Python AST, and then we can convert Python AST to SIR, and we can have a look at SIR, and here is a JSON format of it, and it's not that interesting for humans. But then basically we can convert this to C++. And to convert this, we will actually use the Dawn comments directly, because it turns out in notebooks, there's this unfortunate issue where errors are only displayed if you use the command line tools of Dawn. But if you use the Dusk API to convert to C++, then you don't see the error messages. But this is basically given here an example of how to use the command line, and then you will get error messages. And then with this, we write our SIR into a file with these statements, and then we can convert this file from SIR to C++, and it will be written. Hang on, I need to execute this real quick. So basically, we execute these here, and basically, this will. Sorry, I'm in the wrong folder. So this will kind of write a C++ file into our intro folder, so in the same folder of this as this one, and I can also have a look at it and open it in an editor if I really want to. But also this C++ code is not that readable. And then we can execute Clang format on it. And after that, we can use the make command. So for all the exercises, there's a make file prepared to create a runner, and then the runner can execute. And then here it says, well, A was 1, and that's what our original stencil computed. It just assigned the field A to 1. I also want to show you some error messages that you might encounter as you solve the exercises. So the first kind of thing that can go wrong is that the Python syntax was wrong. Here is a missing bracket. There should be one here, and then Python will just say, well, hey, there's a missing bracket basically. Then the next kind of error is that you get a Dusk error. So for example, here we have an undefined variable that we use, and this is not a Python error because of Python's dynamic nature, but in Dusk we want kind of static safety. So this will be a Dusk error, and if we execute it, we don't get an error yet. And the reason for that is that we first need to translate it. And after we've translated it, we will get an error message. So this is a very long stack trace. And if we scroll to the bottom, at the bottom, it will say, well, it says here undeclared variable, undefined variable, and that was actually the issue. So we try to kind of have some error messages that are useful for Dusk. And then after Dusk has translated this to SIR, the next thing that can go wrong is DON errors. And in this case, we have an error where we assign a cell field to an edge field. And there's actually a lot more edges than there are cells. So this is not really this is a nonsensical statement in this context. And if we execute this, what we will get is DON will kind of crash, and this error message kind of looks like this, and this kind of, so this is a check that DON carried out, and this failed here. And then the last thing that can kind of fail is a C++ errors. So in this example, we changed the signature. So we added this B field here, and our driver was made to have only an A field here, right? So these are API fields, and they have to be compatible with the driver. And this B field here, you should not have it in there. And if you do this, you will get an error message, and it says, well, this stencil expected 4 arguments, so 2 of those are kind of mashed up, and then the other 2 are this A and B, but only 3 were provided because this driver coded was not made for this B parameter. It should only be 1 parameter, and you will get a crash like this. Also, you have to make sure that that you don't change the name. So this driver code was made for a stencil named simple example stencil. And if you change the name to a name such as a different name, then you will get an error. And because the signature changed, and let's see what this error looks like. So it says, well, it was looking for this member, but it could not find it because we renamed the stencil. And then also after we compile all of this, the runner can crash. So in this example, we do a division by 0, and because the naive backend does no optimization, we don't really, we propagate this to the code and we compile it. And when we execute this kind of trivial 0 division, what will happen is that it will crash with the 0 division. And here we'll see, well, there's a floating point exception that occurred when we run, and then that's kind of what we expected. Now, Dusk is kind of very picky with legal statements. So, for example, Python has this in expression, and Dusk has no support for it. And what will happen is that Dusk will complain, and basically you get this long stack trace again. And at the end, it says, well, this is an unsupported operator. So many language elements of Python are just straight up disallowed. And then here's another example with list comprehension. So this is a list comprehension, and this is not allowed by Dusk, and what you will get is an unrecognized node kind of exception. So this is kind of unrecognized nodes usually means that you either did something that wasn't supported, or you did something that was supported, but you kind of did it in a wrong way, or like you expressed the code in a wrong way. And then here there's a small section about positional and keyword only. Well, about positional and keyword arguments. This is a very simple introduction to Python positional and keyword arguments, and I will not go too much into this. If you're familiar with this, you can skip this. If you are not sure about this, then you can look this up and then read this. And this is a simplistic introduction, but for Dusk, this is more than sufficient. And like I said, so if you look at these old folders, in the intro folder, there is this notebook. So if you something wasn't clear, or you have an issue during the exercises, then you can look up this introduction anytime you want, and you can have a look at the code samples. And basically, then the idea is that we solve this exercise here. So that's kind of the first exercise. It's a hello world exercise. And this is, so if we start in the kind of the root location of this Jupyter Lab instance, then there's this first exercise folder. And if I open this, then there's this Jupyter notebook, this IPyNB that I can open, and this will open this exercise notebook. And here we have kind of 4 small exercises. One where you just have to compute, where you just have to add 2 fields together. Then the next exercise is kind of you compute this. Oh, there's something cut off. But then the next exercise is, there's some issues with font rendering. But I think this is because of my low screen resolution. I've never seen this before. But anyways, if you, the next exercise is to compute this kind of expression here, and what you will get is kind of this plot of this absolute value norm. And then then we have 2 more exercises that are kind of inspired by image processing techniques. So those are all still pointwise stencils, and basically you can load an image here, and it will transform it into a form that the runner can read. So we are using here the logo of ESiWACE. Actually, we're using a small version of it. We load this and we convert this into like a triangular mesh. And if you feel adventurous, you can upload your own image, but be careful that big images can take a long time to process. So it's probably easier to work with this ESiWACE image. And then basically what we do first is we compute a black and white transformation. So this is the original, and this is what the logo looks in black and white. And the goal is to get your computed version to be a black and white image. And at the end, we kind of we apply this curve here to every single RGB channel in the last exercise, where we do an oversaturation computation. So we provided you here with the formula. And when you get this right, you can get an image like this, where you kind of have the original image, and then kind of what you should get is an image where all the colors are heavily kind of unnaturally oversaturated. And that's kind of the last exercise. And this is kind of also a pointwise stencil, but this time it kind of involves a bit a more complicated formula here. And I mean, if you're encouraged to experiment with this notebook a bit, and if you want to use your own image, you can only plot your image after you've transformed it. There's a function for this as well. And that's kind of, I think it's a nice kind of hello world exercise that you can start with. So yeah, that's it for the introduction to the exercises. If you have questions, please don't hesitate to write us on Slack. We're really don't mind helping you. I think we're really looking forward to hopefully quite some participation here. And yeah, we really would like to encourage you to ask us if you need anything. We really hope that you're going to have a smooth experience here.